Hello, welcome to this video. Today we're going to look at this problem. So, AN is a series that follows A1 is equal to 2, and generally AN plus 1 is 1 minus 1 over AN. Find the sum of the first 2021 numbers in this series. So, first thing we're gonna do is use some sort of trick which is similar to the trick of last video. So what we're gonna do is just look at AN plus 2 in terms of AN, and then plus 3 and AN plus 4, and hope that eventually we'll get AN. AN, which is like what we got last video when substituting it constantly over and over until we got the same thing. And we're doing that because then it would be much simpler to calculate the first 2021 numbers, which is a big number to calculate. So by this rule, of course, we already know AN plus 1. Let's look at AN plus 2. So, by this rule, AN plus 2 is equal to 1 minus 1 over AN plus 1. We simply replace N with N plus 1 here. And then we get that is 1 minus 1 over 1 minus 1 over AN, which, if we simplify this, we'll get that, first of all, this 1 minus turns into AN minus 1 divided by AN, and then 1 divided by that. This AN will hop from the denominator here to the top, which will give you 1 minus AN divided by AN minus 1, and we will get that this is N minus 1 minus AN divided by AN minus 1, which is minus 1 over AN minus 1. So no luck, this isn't equal to AN, but no worries, we'll keep trying with AN plus 3. So, AN plus 3 is 1 minus 1 over AN plus 2. Again, simply replace N here with N plus 2. And then, what we get is 1 minus the reciprocal of this, aka 1 plus just the denominator here, because the negative and reciprocal cancel. So we get 1 plus AN minus 1, which is just what we wanted to find. So we got that AN plus 3 is equal to AN for any N, which means that we have a cycle of 3 values that keep repeating. And because A1 is equal to 2, we can calculate the first 3 values and know that the other ones are just going to be replicas of the first 3. So A1 is equal to 2, meaning that A2 is 1 minus 1 over A1, which is 1 minus a half, which is a half. And then A3 is negative 1 over A1 minus 1. We just found it. So we know that this is negative 1 divided by 2 minus 1, which is negative 1. Okay. Now, we know with the fact that a1 is equal to 2, again that this cycle repeats because an plus 3 is equal to an. So a4 will be equal to 2, a5 will be equal to half, a6 is equal to negative 1, and then repeat. a7 is equal to 2, a8 is a half, and so on forever. Meaning that our first 2021 numbers will look like this. So I'll have 2, then a half, then negative 1, which are the first 3 values, and then repeat. Like we said earlier, 2, 1 half, negative 1, 2, 1 half, negative 1, and so on until, well, where do we end? So, because this is a triple, 3 numbers that always repeat, it means that for any any multiple of 3 amount of numbers will end in the last digit, which is negative 1, which you can and you can clearly see that the first 3 negative 1, then another 3 will give you negative 1 because n plus 3 is equal to an, and so on and so forth. Meaning that because 2019 is a multiple of 3, the first 2019 numbers will end in negative 1. And then the number in position 2020 will cycle us back to 2. And then finally 1 half. So these are the first 2021 numbers. Now let's calculate their sum. So, first things first, we know that we know that the first 2019 numbers and negative 1 and 2019 is divisible by 3, so we can split 2019 into triplets, specifically 673 triplets, since 3 times 673 is precisely 2019. So, and the sum of each triplet is the same. 2 plus a half minus 1, which is 1.5. And then we'll have 673 times that sum. And then we simply get the last 2 numbers that are not in a triplet, which are 2.5. So, this sum, like we said, is equal to 673 times, because that's how many triplets there are, times the sum of all numbers in each triplet, which is 1.5, and then plus the last 2 numbers, which are not in any triplet, which is plus 2.5, and we get that is equal to exactly 1012. And that's it. If you want more content like this, please subscribe to my channel. I'll be uploading more things like this in the future. And finally, that's it.